Alright class, in today's video we're going to be going over the solutions to problem set number 1. Again, just a reminder, my recommendation for this video is you do not need to watch every single second of the video, start to finish. My recommendation would be to just skim through the video at first, kind of check your answers to each problem, and then if you find that there are certain problems or part A or part B that you had trouble with, got the wrong answer to, I would watch just that individual section of the video. Again, if you get a question right, do not feel like you need to watch the entire explanation. Again, if you know and feel confident with that particular type of problem. So look at this first one. So we have this tourist who is walking throughout DC. We're told they first walked forward down Constitution Ave for 57 meters, before turning around and walking backwards 44 meters. And then from there, they pull out a map, realize they're going the right direction the first time, and then walk back 121 meters forwards until they finally reach the Washington Monument. So again, my recommendation for all of these is draw a little quick sketch just showing what direction our person is moving in. So again, we first go 57 meters forward, then 44 meters going backwards, and lastly 121 meters going forward. Now, when we're trying to figure out the total distance we traveled, again, find total distance. Distance is a scalar, so the direction we're moving in is not important. All that matters is how many meters we're mapping out here. So all we're going to do is add each individual leg of our journey together to get the total distance traveled. So we'll add our 57 meters to then our 44 to our 121 meters. That total gives us 222 meters as the total distance we have traveled. Again, we get that just by adding everything up together. Now for displacement, that's a little bit more challenging just because displacement is a vector quantity. Basically means the direction is going to be important to us. So very first thing we want to do is establish one direction to be positive, one direction to be negative. So I did it over here to the left. Again, it really is kind of up to you. It's really personal preference. Like, we could have done this question calling backwards the positive direction and forwards the negative direction. We still would get the same correct answer. But in this case, just thought that going forwards made a little bit more sense for positive. Going backwards made a little bit more sense for negative. So what that means for our calculation is because we start out by going 57 meters forwards, again, forwards is the positive direction, that means we should have a positive 57. We then go 44 meters going backwards. Again, backwards is our negative direction, so we want to subtract that number. So we'll have subtract 44. And then lastly, we go 121 meters forwards, back in the positive direction, so we're going to be adding 121. So 57 minus 44 plus 121 gives us 134. Now, because this answer we just got here was a positive number, right? That's giving us information about our direction. So because we have a positive direction, that just means we've gone forward from our starting point. So when we describe our overall displacement, we can either say it's 134 meters forwards, we can say it's 134 meters in the positive direction. Both of them would be valid answers for us. Now, moving into question 2, we have this traveler who's traveling up and down I-95, going north and south. So they start off by going 66 miles going south. From there, we are then going to go 117 miles north, shown on our picture. From there, we continue on up another 45 miles going north before we finally drive back south and go 34 miles. So again, finding distance, all we do is add up each individual piece of our motion. So we have our 66 plus our 117 plus our 45 plus our 34. Add those all together, we get 262 meters as the total distance we have traveled. And then for this one, for finding our displacement in part B, all right, what I did was I went ahead and called north the positive direction, south the negative direction. Again, this problem would work if we instead made south positive, north negative. Although what happened was we would have a different sign for our final answer for a calculation. but the overall determination of have we gone north or south, that will be the same no matter our coordinate system. So this one, if I say north is positive, south is negative, our first motion south would be in our negative direction, so we'll have a negative 66. Our 117 meters north is positive, so we'll add the 117. Our 45 miles north, again, still in positive direction, so we'll add that as well. And then lastly, our 34 miles going south. Again, south is going to be our negative direction, so we'll have to subtract the 34. Now, because we get an overall positive number for a positive 62 here, the positive number is just telling us that we've determined that north is positive direction for this problem. So once we decide which direction is positive, which one is negative, as long as we keep that consistent throughout the problem, we'll get the correct answer for our final direction. So next up, we have this person who's going to be starting off at the Rockville Metro Station. Right, their job is to ultimately get to Grosvenor, but they end up they missed their stop. They take an extra stop, so they go from Rockville to Twinbrook to White Flint to Grosvenor to Metro Center. They then have to go back from Metro Center back to Grosvenor to their final destination here. So when we think about the total distance we have traveled, so our first leg of our journey, we're basically, as we go from Rockville to Twinbrook, that's 1 stop. To White Flint, that's 2 stops. To Grosvenor, that's 3. Grosvenor to Medical Center, that's 4. So we go through 4 stops. Again, we're making this assumption that every single station is 4,350 meters away. So we multiply 4 stops by 4,350. That gives us our 17,400. That's how far we travel for the first leg of our journey. Our second leg of our journey is the 1 stop. We go from Medical Center back to Grosvenor. So that 1 stop adds an additional 4,350. And we add that together to get our total 21,750 meters as the distance we've traveled. Now, when we think about our displacement, though, again, really just worried how far do we have to go start to finish. So there's a couple of ways of thinking about this. So one way we could kind of use our same adding in the positive direction, subtracting the negative direction as before, is if we took our 4 stops that were going south, if we call that our positive direction, we would then have this positive 17,400. And then from there, we want to subtract the Medical Center back to Grosvenor because that's going north, which is what we're calling the negative direction. So by subtracting that additional 4,350, we get 13,050. Basically, means we've traveled 13,050 going south. The second possible way we could do this is we could just say, when we're finding displacement, the only thing that matters is where do we begin and where do we end. So if we begin at Rockville and we end at Grosvenor, our, in essence, total net trip is we go from Rockville to Twinbrook, so 1 stop, Twinbrook to White Flint, 1 stop, White Flint to Grosvenor, 1 stop. So we've gotten 3 stops in total start to finish. If we multiply 3 by our 4,350 number, that's going to get us to our 13,050 meters as well. So either way, setting this problem up works for us. For question 4, we have this runner who is going to leave from their house and jog 6.5 miles going to the east. They then turn around and run back 10 miles to the west. And then for their last and third leg of their journey, they then head home and they finish the run where they started. So our job of trying to figure out our total distance is we know the lengths of 2 out of our 3 legs of our journey. We know we started off with the 6.5 miles and we run the 10 miles as well. What we don't yet know is how far do we have to go from the end of our 10-mile point back to that starting point where we get to the house where we end the run. So if we think about going 6.5 miles east and then going 10 miles west, so out of those 10 miles, 6.5 of them are getting us just back to that starting point where we're even with our house. The additional amount that we have remaining, that just ends up being 10 minus 6.5. So that means we have 3.5 miles that we continue on going west of our house. So after our second leg, if we end up 3.5 miles west of our house, we then have to run 3.5 miles back east to get us to our starting point. So our total distance, we just want to add up those individual legs. We have the 6.5 going east. We have the 10 miles going west. And then we have that last leg of our 3.5 miles going back east, giving us 20 miles in total as the distance we've traveled. If we think about this for our displacements, again, let's say east is positive direction, west is negative direction. We go a positive 6.5 miles east. We go then a negative 10 miles going to the west. And then we go a positive 3.5 miles going to the east. Now, what we end up finding is that we end up getting 0 as our answer here. Again, 0 displacement, all that's basically telling us is we have the same starting and ending points. Right? We begin the run at the house, but we also end the run at the house. So very similar to our person who's running a 400-meter race around a track. Right? If our starting and our ending point are the exact same, that means we have no overall total displacement for that vector quantity. So for our last question to this play, we're told that the St. John's football team has the ball in their own 10-yard line. All right, quarterback with the shotgun and hikes the ball, so it's going to move back 3 yards. From there, our quarterback then throws the ball forward 32 yards to our wide receiver. Wide receiver catches it, and then in an attempt to evade a defender, is going to then run backwards 5 yards where they eventually get tackled to end the play. So if we think about kind of the individual pieces of motion here, so even though the ball starts on the 10-yard line, right, that's not actually a movement of the football that takes place during the play. That's just giving us our starting position information. So the actual movement of the football is we first have the hike where we go back to 3 yards. We then throw the ball 32 yards forward, and then the wide receiver carries the ball backwards 5 yards. So total distance here, we just want to add our 3 to 32 to 5. That's then going to give us a total of 40 yards as the total distance traveled. If we think in part B about our displacement, again, always want to set up positive direction versus negative direction. So we'll call anytime the football is going forward, positive, anytime it's moving backwards, the negative direction. So when we hike the football to the quarterback who is in shotgun position, the ball is going to move backwards 3 yards. So we'll have a -3 there. The throw from the quarterback is then going to be forwards, so positive 32 yards. And then when our wide receiver runs backwards 5 yards to avoid the defender, right, backwards is negative direction, so we'll subtract the 5. So -3 plus 32 minus 5, that gets us a positive 24. Positive just basically means our football has moved forward from our starting point. So if we're trying to then figure out what is our football's final position relative to the goal line, right, basically we're asking what yard marker does this play end up at. So if our play starts at the 10-yard line, we then gain 24 yards through our displacement. It means we're going to then end up at the 34-yard line where our play will now end.